Hello, everyone. My name is Marco, and today I want to talk to you about a project in deep learning for IMDb movie review sentiment analysis. So, the goal of this project is to implement a deep learning model to perform sentiment analysis on an IMDb movie reviews dataset. A dataset has 50,000 reviews that is evenly split between positive and negative reviews. Um, we build and compare neural network architectures to classify movie reviews as either positive or negative. So obviously we're going to be using part of that data set to train the models and part of the data set to test the model. The objectives here is to implement effective text processing for movie reviews, design and train two different deep learning architectures, optimize model hyperparameters for best performance, compare and analyze model performance metrics to see which one is the best model for this project, both when it comes to the time that it takes to run the model, but also the accuracy of the model, and then providing insights into the sentiment classification effectiveness. Um, Data set is binary, so it's positive and negative. If we were to take a look at the CSV file, we would see the reviews as one of the features, and if that is a positive or a negative review as another feature, as another column. So the steps that we took here was so data processing first, so text cleaning and normalization. There was a lot of HTML tags that needed to be removed, some special character handling that didn't add much to the model training, and then just some white space standardization. The models we used was LSTM for long short-term memory network, and then also CNN convolution neural network. The evaluation metrics was accuracy and precision, recall, F1 score, and we also had a confusion matrix. Some of the technologies we used was Python, TensorFlow, Keras, NumPy pandas for data handling, Matplotlib, Seaborn for visualization. So let's get into it. We start here by taking a look at the data. So as you can see, we have 50,000 reviews. Here's the head of our data set. You can see here the first review is positive, the second one is positive, and so on. Again, it's half and half, so half of them are going to be positive, half of them are going to be negative, which is great for training and then for testing as well. So we're gonna start by splitting the data here into training and testing sets. We can see here that we used 80% of the data for training and 20% for testing set. As I mentioned before, half of the data is positive and half is negative. Let's start with our exploratory data analysis. The count here, again, 50,000. There are 49,582 unique reviews, so a few repeated reviews there. 25,000 positive, which would leave another 25,000 to be negative reviews. As shown here in this distribution of sentiments, they are exactly the same. Moving on here to the distribution of review lengths. So part of training the model is making sure that the reviews have an appropriate length. Reviews that have too few words or too many words might affect the way that the model is trained. So we can see here that the vast majority of reviews have about, let's take a look here. Let's see. So 1,294 is the average length of characters for the reviews. More important than the characters is the word count. So let's go down here. We can see that almost 14,000 reviews have about 229 words for negative reviews and 232 words for positive reviews. So let's see how many HTML tags we find. So many reviews have between 0 and 5 tags. So HTML tags is not something that we want in our data set. It's not something that is going to be useful, and it's important to visualize how many we have so we know how to proceed with data cleaning later. So we can see here that there is an average of 4 tags per review. Obviously, some reviews will have 0 and some reviews will have more. All right, so some of the key findings here for our EDA was the data is very balanced, so half positive, half negative. Text length characteristics, so the length varied widely. The range is actually between 100 and 500 words. And also there was no significant difference in length between positive and negative reviews, which is very interesting. Data quality, so no missing values in the data set. HTML tags are present, so need to be removed. Text length and word count show moderate correlation with sentiment. So here's the required transformation that we need to apply on our data set. So we need to remove HTML tags. We need to do text normalization, lowercase, and remove special characters. We need to truncate very long reviews to a max length, and we need to do tokenization and padding that will be added for the deep learning models. All right, so here is the plan. Remove HTMLs, convert to lowercase, remove special characters and numbers, remove extra white space. So that's what we're going to do first. It's a simple Python clean text function here. So here we're going to remove the HTML tags, remove the white spaces here. Remove characters and numbers, keep only letters and spaces. We can run the function here, and we can see that the data has been cleaned. So let's show what was done here. So for the results, we create a new column, clean review with processed data. We preserve original reviews for reference, simplify text while maintaining core content, and it was faster processing with minimal memory usage because, as you saw, we did not use any special Python libraries except for the built-in libraries. So let's take a look now at the text length analysis after the cleaning. We can see here that the length decreased a bit. So from 231 on average words per review, we now have 226 words per average. Let's take a look at the vocabulary analysis. So we can see here some of the most used words, most frequent words. So no surprises here. So some articles and some prepositions, the and a of. This is very common when you're looking at text. And then no surprises here as well. The word movie is in the top 20 as well. All right, now let's make sure our data is prepared for the deep learning models. So let's do data preparation here and text vectorization. So a very important aspect here of preparing our data for the models is that we're going to split it into the train sets, validation set, and then the test sets. We can see here that another portion of data cleaning here is that we converted the sentiment label, so positive and negative, into a numerical value of 0 and 1. We converted text to sequences. We applied tokenization. We padded the sequences, and then we converted it to float. And finally, we have a distribution here of the training and the test set. So the training set have 35,000 rows and 250 features. All right, so we have floats here for our data types for training, and then the label distribution. So we have a training set of 17,581, validation set of 3,689, test set of 3,722. So the first model that we used was LSTM with hyperparameter optimization. So we build our model here, and then we ran our model, and we will talk more about results later, but as a preview, we got 88% accuracy, and it took quite a bit of time to run, so it took about 20 minutes, which is not ideal, especially for a data set that has only 50,000 columns or rows, excuse me. But it was a pretty good result for a first try here with 88%, almost 89% accuracy. Second model that we used to compare with the first one was CNN with hyperparameter optimization. So again, we built the model here and then run the model, and we saw very similar results when it comes to accuracy. However, it ran much faster than the previous model, which, it's important to have this information here when trying to decide which model to use. One of the things I wanted to do here is compare the models. So I used some libraries here so we can visualize, so we can create plots. So let's take a look at that. We can see here when we ran the second time, the test accuracy went to 0.876 and 0.8724, which shows they're very, very similar. So I really like this graph here because it clearly shows that as the epochs progress, the loss function decreases and the accuracy function increases for both models. So it starts here at around 50%, which is very typical, and it goes down to under 20%. In this confusion matrix,